This lesson will refresh your knowledge of Python programming, particularly as it relates to robotics applications. Due to the fact that we will use Python to program our robot arm, I thought it would be nice if you refreshed your memory about the topic from a robotics perspective. So let's get started. Python is one of the most popular programming languages because it's easy to use and beginner-friendly. Python's core functionality can be extended with packages that can be downloaded, installed, and imported. Therefore, it's highly extensible through packages, giving the user instant gratification. Since we will be using Ubuntu 22.04 to run our ROS2 and to code, then first we make sure that we have Ubuntu on our computer. You should have installed it by now. If not, refer to the first lab. Then we need a code editor to write our Python programs. In the past, people were using just text editors to write their programs, but thanks to the current code editors, we can get the most of their debugging properties. These code editors are called IDEs, or Integrated Development Environments. There are different IDEs, and some are specially designed for Python. In this class, we're going to use Visual Studio Code Editor from Microsoft, and it has the advantage that you can organize your codes in different languages in one place, and it's the most widely used code editor among programmers. Other options are PyCharm and Spider that we wouldn't use them, but you can take a look at them if you're interested. Here are the steps to install VS Code and Python in Ubuntu 22.04. First, you should open a terminal. And by now, you should know that you can open a terminal by Ctrl-Alt-T. Then type this command into a terminal and click Enter. This is the same as going to the Software Center and typing Visual Studio Code and then installing it. Now, head over to All Apps and add the VS Code to your favorites. Now open up the VS Code. Then go to the Extensions tab and search for Python and get the recommended Python extension. Click on the gear icon, then extension settings, then configure it as you want, like setting your desired paths for things like Conda virtual environments. If you don't know, a virtual environment is like the constructs in the movie Matrix, where Morpheus trained Neo. And the reason to use them is that some packages that you may have developed for different projects have conflicting dependencies. For instance, if you want to work on a machine learning project using Python 3 and the web development project on Python 2, this is not possible since the system can have only one default Python. In this case, you will need to install a virtual environment. We have a tutorial on Mechanism that teaches you how to install virtual environments if you've ever needed in your projects. You can also install a C, C++ extension if you need to program in those languages as well, or if you want to use ROS packages that use C++. Now, write your very first program and test your IDE. For this, open a new folder. Give it a name. I named it, for example, Intro to Python. Then create a new Python file and name it Hello World. Now you can write your first code. We will type print and then Hello World between two quotation marks. And then you will see that if you execute this program, you will see that Hello World will be printed on the console. And the place that you see the code is printed is called the console. The first line that starts with a sharp sign is just for human users to understand the code, and it's called the comment. Two quotation marks is used for strings. Print will print anything that you pass to it onto the console. Congrats, you have written your first code in Python. Now let's go to the next part to learn about variables and data types in Python. A variable is like a container that stores data. It can be a number, a text, or more complex data types. In most programming languages like C++, you need to declare a variable before using it. But in Python, you just give it a name and assign a value to it, and that's it. Different data types that can be stored in variables in Python are numbers, which can be different types like integers and floats, Boolean value, which are either true or false, Strings, which are just plain texts, lists, tuples, and dictionaries that we're going to talk about them in this lesson. Let's first talk about the simplest data types in Python, numbers and strings. Suppose we want to create a variable and assign a value of 10 to it. So we will write the name of the variable, which I named it numInt, and then assign the value of 10 to it. Or we can also assign a float number to a variable, like we can create the name of the variable and then assign a float number to it. We can do basic arithmetic like addition, subtraction, division, multiplication, parentheses, or we can use the power with numbers. For instance, this will print out the result of addition of the first integer that we created with a float number and then multiplying it to the integer number that we created. We can find the remainder of the division using the modulus operator. This will print out the result of the division of our integer number, which was 10, by number 3, which will be 1. There are different math functions that we can use on our numbers. If you don't know about math functions, there are collections of code that we run and can perform a basic operation. Functions can either modify our data or give us some information about the data. For example, max will give us the larger of the two numbers that we give to it. Min is the opposite. For example, this will print out the maximum between our integer number, which was 10 and 9. In this case, it should print out 10. ABS finds the absolute value of a number. So the result of this print would be just a number int, because I pass the negative of it into ABS and it will give me the absolute value of the number. POW, which stands for power, gets the first number to the power of the second number. So this will get the first number to the power of 2 and print out the result, which is 100. Round will allow us to round the number, either round down or up. It depends on the number after the dot sign. If it's less than 5, it will round down. If it's more than 5, it will round up. There are some other math functions that should be imported to get access to them. The math library is a module, and we can have access to those functions inside the math by importing math. We can write from math import start. This means that you can now access all of the functions in the math library without having to prefix them with math dot. Now, if I comment out this import math library, you can see that I cannot access to specific math functions. As you see, it will spit out an error for me because I didn't import math library to access that specific function. Now let's import that library again and run the code again. This time you'll see that it's executed. Floor will chop off the decimal point of the number. So the decimal point for the number 0.5 is 0 and for 1.5 is 1. And Seal will round the number up. For example, because our number is 0.5, Seal will round it up to the number 1. SQRT, you probably know, is the square root of the number. For example, the square root of our integer number, which is 10, is around 3.2. If you write just import math, then to access the functions inside the math module, you need to, for example, say math.that function to access that function within the math library. You can also import a library as a preferred name for simplicity, and of course, if you're lazy. For example, if I write import math as M, then from that time I can use M in order to access the math library. Now let's combine strings and numbers. This is how we can do it. The first round that I executed, you see that I got an error because I didn't convert the numbers to strings, because using a plus sign is for concatenating the strings and not numbers with the strings. So if I want to use the plus sign to concatenate the strings, I should first convert my number to string. So the str function creates a string version of the object passed as an argument to it. So an object is any Python data type. Here we used it to convert a number into a string. The output of this code is there are 10 arm robots in the factory. Half of them are broken. You also see that I add some spaces to get the correct output. Note that here we concatenated different strings, meaning that we added different strings together. Strings can be put between two quotation marks and they can be concatenated with each other using a plus sign. There is also another way to do it, and this time you don't need to just convert the numbers to strings by using apostrophes between the strings and the numbers. So typing this will exactly give the same result. /n will create a new line inside the string. We can also assign a string to a variable. For example, we can do this by the name of the variable and then the string between two quotation marks. Note that here you don't need to use the str function since the factory name variable is already of the data type string, so you don't need to do the conversion. By bracket notation, you can access different characters in a string. For example, the first character in the factory name can be accessed by the variable name, bracket 0. And 2 refers to the third character. You know that indexes in Python start from 0. So you see that the first character is A and the third character is C. We can also use different functions with a string. For example, the lower function can make the factory name all lower. With isLower function, we can check to see if it's all lower and the output should be true because we lowered all the characters in the factory name. Note here that in order to get the true value for the output of the isLower function, we should assign the new value, which is the lowercase letters, to the variable factory name. We can do similar with upper and isUpper functions. You can also combine different functions. For example, you can say factory name.upper.isUpper. This will first convert the phrase to uppercase, and then you will get a true value because it will check that if it's in uppercase and the result is true. We can figure out the lengths of the string using len function. We can also access individual characters using the bracket notations. For example, here I want to access several characters. So this will show the characters from the first character up to 1 to the last character. To know where a specific character is, we use the index function and we can pass it a parameter. For example, in order to know what the index of the A character is, we can write it like this. We can give the replace function 2 parameters. The first one, what you want to replace, and the second one, the thing that you want it to be replaced with. For instance, I want to replace ABC with DEF, and then I will use the replace function. This is pretty much about numbers and strings. You can access the whole code of this section that I wrote here in the GitHub page of this lesson. A list is a data structure that allows you to store a collection of values. Lists are one of the most commonly used data structures in Python, and they're very versatile. You can use lists to store numbers, strings, objects, or any other type of data. Lists are created using square brackets. The items in a list are separated by commas. For example, here I want to create a list of robot manufacturers and their number in the factory. So first I create a robot brands variable and assign some robot manufacturers as the items in a list, and I separate them by commas. Because they are strings, I use 2 apostrophes. I can access the items in a list using their index. The index of the first item in a list is 0. We know that indexes in Python start from 0. The index of the second item is 1, and so on. For example, in order to access the second item in the robot brands list, we would write print robot brands and 1 in the brackets. You can see that Kuka is printed out because the second item in the list is the Kuka brand. You can also use slices to access a range of items in a list. For example, this code prints the first 3 items in the list robot brands, which are ABB, KUKA, and FANUC. You can add items to a list using the append method. For example, if you want to add another manufacturer with the number of robots to our robot brands list, we would just write robot brands dot append and the name of the manufacturer that we want to add to the list. Then you will print out again the robot brands list, and you'll see that the universal robots is added to the robot brands list. You can remove items from a list using the remove method. For example, this code will remove the manufacturer that we just added. So it will remove the universal robots manufacturer from the robot brands list. You can pass the index where you want to insert another item using the insert function. For example, if I want to add universal robot manufacturer to the second index of the robot brands list, I would write robot brands.insert, and then I will pass the index of the second manufacturer, which is 1, and then the manufacturer that I want to insert in that index. You can sort a list using the sort method. The sort method sorts the list in ascending order. For example, if we write robot brands.sort, it will sort the robot brands list in ascending order. You can reverse the order of a list using the reverse method. The reverse method reverses the order of the list in place. You can find the lengths of a list using the len function that we saw before also. The function extend will allow us to get a list and append another list to it. For example, if we want to extend the robot brands list with another list and add 2 more manufacturers to the robot brands list, we would do it using the extend function. The function pop gets rid of the last element in the list. For example, robot brands.pop will get rid of the last manufacturer in the robot brands list. Now I want to check if a certain value is in the list and also get the index of the value. So if I write robot brands.index and the name of the manufacturer that I want to check if it's in the list, it will first check if it's in the list, and if it is, it will give me the index of the manufacturer in the list. We can also count the number of times a value is repeated. For example, if I want to understand how many times the ABB manufacturer is repeated in the list, I would do it by robotbrands.count, and I will pass ABB to it. The copy function, as you may guess, makes a copy of a list, and you can put the items in another list. You can iterate through a list using a for loop. The for loop will iterate through the list, and it will assign each item in the list to the variable that you specify. For example, here I want to iterate through the robot brands list and print each item. Clear function will remove everything. You can see that by writing robot brands.clear, it will remove everything. Lists are a very powerful data structure, and they can be used to store a wide variety of data. You can access the whole code that I wrote here in the GitHub page of the lesson. The lists that we talked here are all one-dimensional lists, but in Python we can also create 2D lists. That is the topic of the next section. Python, a 2D list, also known as a nested list or a list inside another list, is a list that contains other lists as its elements. It allows you to create a grid-like structure where each element represents a value in a row and column format. To create a 2D list in Python, you can use the syntax. Here, matrix is the name of the 2D list. You can choose any valid variable name you prefer. Element 1, 2, 3, etc. These are the individual elements within the 2D list. They can be any valid Python data type, such as numbers, strings, or even other lists. So now let's create a 2D list representing a 3x3 grid. This creates a 2D list called matrix with 3 rows and 3 columns. You can access individual elements within a 2D list using the row and column indices. The indices start from 0, so the element in the first row and first column can be accessed as matrix bracket 0, bracket 0. So it means that it's the first row and the first column of the matrix. The element in the second row and third column is matrix bracket 1, bracket 2. 1 is the second row and 2 is the third column, and so on and so forth. 2D lists are useful for representing grids, tables, and matrices in Python. They provide a flexible and convenient way to store and manipulate data in a tabular format. The whole code that I wrote here is again in our GitHub page of this lesson. Let's now go to the next section and talk about another data type in Python, which is a tuple. Another data type that we can store it in a variable is a tuple. In Python, a tuple is an ordered collection of values. Tuples are similar to lists, but they are immutable, which means that they cannot be changed once they are created. Tuples are created by enclosing a comma-separated list of values in parentheses. For example, robot engineers is a tuple of robotic engineers in a factory. Tuples can be indexed and sliced just like lists. For example, robotic engineers 1 is the second value in the tuple. Tuples can also be unpacked into multiple variables. For instance, in this code, we unpack the tuple into the variable E1, E2, E3, and E4, and we can print out each item in the console. Tuples can be used to store any type of data, including strings, numbers, lists, and other tuples. They are often used to store data that doesn't need to be changed, such as the names of people in a group or the coordinates of a point on a map. If we try to change anything inside the tuple, we'll definitely get an error. It's also possible to make a list of tuples. For example, robotic partners is a list that contains multiple tuples. You can print out each tuple by its index. The whole code that I wrote here is again on the GitHub page of our lesson. In the next section, I will talk about another data type in Python, which is called dictionaries. The other data type is dictionaries. A dictionary is a data structure that stores data in key value pairs. We can create these pairs, and when we want to access the info, we can refer to it by its key. Keys are unique and they cannot be repeated. They are case sensitive and they can be any immutable type, such as strings, numbers, or tuples. Values can be of any data type. You can access the values via their keys here. To create a dictionary in Python, we must enclose a sequence of elements inside curly brackets and separate them with commas. Here, we want to see an example. A robot arm is trying to sort the objects in its environment based on color. We want to make a dictionary that maps the name of the object to its color. First, we create a dictionary that maps the name of the object to its corresponding color. And then we can access to those object colors using their keys in the dictionary. Here you see that I used get function to retrieve the value associated with a key. If the value is found in the dictionary, it returns the corresponding value. However, if the key is not found in the dictionary, which in this case, it's not in the dictionary, it returns the default value provided as the second argument to the get function, which is no such subject. As another example, we want to create a dictionary for a robot arm with 3 revolute joints. And this dictionary has 3 keys corresponding to the 3 joints in a robot arm. Each key has 3 values: the minimum angle, the maximum angle, and the default angle. The minimum and maximum angles define the range of motion for each joint, while the default angle is the angle that the joint is set to when the robot arm is first turned on. So armDict is a dictionary that maps robot arm joints to their corresponding minimum, maximum, and default joint angles. We can also access the keys and values in this dictionary. So here's an example of how we can access the value of the key joint 1 in this dictionary. This code will give the same result, but with one difference. If you type the key incorrect, it will spit out not valid instead of like crushing the program. You can also access to individual angles within each joint in the dictionary. This code gives the maximum angle of joint 2. You can also print, for example, the minimum angle of joint 3, and you can just print out every information from the dictionary that you're interested in. So these were the most common data types in Python. In the next section, we'll talk about functions and the return statement. A function is a block of code that performs a specific task. It can be used to group related code together, make code more reusable, and make code easier to read and understand. The return statement is used to exit a function and return a value to the caller. The value that is returned can be any Python object, such as a number, string, list, or dictionary. After the return, no code will be executed because when Python sees the return keyword, it will break out of the code. Functions can be passed data in two ways. The first one is arguments, and arguments are passed to a function when it's called. They can be any type of values such as numbers, strings, lists, or dictionaries. Or they can be passed parameters. Parameters are variables that are declared in the function definition. They are used to store the values of the arguments that are passed to the function. As a very basic example, we want to write a function that gets two numbers and returns their sum. A function in Python is defined by the keyword def, and then we can give it a name, pass it its variables, and then return what we want it to be returned, in this case, the sum of two numbers. Here, a and b are parameters because they are declared in the function definition. So this add function takes two numbers as input and returns their sum. When we want to call the function, we pass arguments to it. We can call this function by passing arguments to it and storing it in a variable and then printing that variable in the console. Let's see another example. Suppose that we want to write a function that gets the radius of the wheel of the robot and returns the wheel area. Because we would use pi in the calculation of the area of the wheel, then we should import the math library because other than that we cannot access to that. So here we will pass the parameter radius to the calcWheelArea function, and then the function will return the area of the wheel, which we all know that it's pi times radius squared. In order to call this function, we should pass the wheel radius argument to it and print out the area of the wheel. In the next section, we'll talk about if statements. In Python, the if statement is used for conditional execution. It allows you to execute certain blocks of code based on whether a specified condition is true or false. So if a statement syntax is like this, we would write if condition, and if this condition is true, then the code under this line will be executed. And when we say else, the code under the else will be executed if the condition is false. Here, note that else statement is optional, so it's possible that your if statement doesn't have this else statement. With if statements, you can compare Boolean values or numeric or string values. Let's see an example. Let's say you have a robot arm with 2 joints, and you want to control the movement of the arm based on the input from a joystick. If the joystick is tilted to the right, the first joint should rotate in a positive direction based on the right-hand rule. And if the joystick is tilted to the left, the first joint should move in a negative direction based on the right-hand rule. Similarly, tilting the joystick up means moving the second joint in the positive direction, and tilting the joystick down means moving the second joint in the negative direction. In order to write the code for this, we should first get the joystick input. If the joystick input is right, then the first joint should be moved in positive direction. And if the joystick input is left, then the first joint should be moving in the negative direction, and so on and so forth. Like for the up, the second joint should be moving in positive direction, and for the down, the second joint is moving in the negative direction. And if none of these is true, then the joystick is in neutral position, so there is no movement. Note that this is an imaginary situation, and in a real situation, you should read from the joystick input data and input the real data to the program, and then command the joint motors to rotate accordingly. Let's see another example. Let's consider a mobile robot that's equipped with 2 proximity sensors that detect obstacles. If any of the sensors detect an obstacle within a certain range, the robot should stop and display a warning message. Otherwise, it should continue moving forward. In order to implement this for an actual scenario, we should read from our sensor data and then command the motors to do the action that you want the robot to do. But here, we would suppose that we have read the sensor data, and we also define the threshold distance for considering an obstacle in meters. So if it's less than that, then we know that the sensors detect the obstacle. The condition here is that if at least one sensor detects an obstacle, for example, its reading is less than the safe distance or the threshold distance, the code block under the if statement is executed, and it will print the warning message and performs additional actions to stop the robot. If none of the sensors detect an obstacle, the code block under the else statement is executed, and it will print out moving forward and performing additional actions for the robot to move forward. Let's also see a general example. We want to write a Python code that gives us the minimum number that we pass to it. In this example, we want to write a function that gives us the minimum number of 3 numbers that we pass to it. The Boolean table for this looks something like this. It means that if A is smaller, then the minimum function should give us A. If B is smaller, it should give us B. If the C is smaller, then the minimum function should give us C. If all of them are equal, then the minimum function should spit out equal. So here's how we can implement this. We would define a min number function, and we will pass 3 parameters to it, A, B, and C. And we will exactly implement the Boolean table. So if A is the smaller number, then it should return the smaller number, which is A here, and so on and so forth, until all the Boolean table is implemented. We can call the function by writing its name and passing 3 arguments to it. Here I also added some descriptive text to have a nicer output. The next section will talk about while loops. In Python, a while loop is a control flow statement that allows you to repeatedly execute a block of code as long as a certain condition is true. The general syntax of a while loop in Python is something like this. So to summarize how a while loop works, we can say the condition is first evaluated. If it's true, the code block inside the loop is executed. If it's false, the loop is exited and the program continues with the next statement after the loop. After executing the code block, the condition is checked again. If the condition is still true, the code block is executed again. The process continues until the condition becomes false. It's important to be cautious while working with while loops to avoid infinite loops. An infinite loop occurs when the condition always remains true, causing the loop to execute indefinitely. To avoid this, ensure that the condition eventually becomes false. While loops are very flexible and can be used in various situations. They are particularly useful when the number of iterations is unknown or dependent on a certain condition. As an illustrative example, suppose that we have a robot that will move forward until it encounters an obstacle. So this is a good situation that we can use a while loop here. First, we write the move robot function that simulates the robot's movement. So the robot moves forward until it encounters an obstacle. So we should simulate the time it takes for the robot to move forward by giving some delay. We will import the library time and then we will use the sleep from that library to give robot some delay. Then we will print that the robot has moved certain distance units. Note that F apostrophe is used to create formatted strings, also known as F strings. It's introduced in Python 3.6 and allows you to embed expressions inside strings. Here you see that I embedded the distance inside a string and I don't need to change it to a string when I'm executing the code. Now we should write a function for obstacle detection. Here we use the random library, so we should import it. And the random.choice function is part of the random module in Python. It allows you to select a random element from a sequence such as a list, tuple, or string. Because we are simulating a situation here and we don't have real obstacles, we randomly choose whenever an obstacle is present. Here we get the robot's initial position and we start from the 0 position. And we will keep moving the robot until an obstacle is detected. So here we will use a while loop for this, and we should generate a random distance to move forward because we are simulating and it's not a real scenario. Then we should call the move robot function to move the robot forward by the randomly generated distance. Now we should add this distance that the robot has traveled to the initial position of the robot, and we should update the position of the robot here. Note that here the while loop continues to execute as long as the detect obstacle function returns false, meaning that there is no obstacle. If it becomes true, then it means that there is an obstacle and the loop is exited and a message will print showing that there is an obstacle. When an obstacle is detected in a real scenario, the control system of the robot should take action accordingly and should command the actuators to stop the robot. So when the obstacle is detected, the robot should be stopped, and here we also print the final position of the robot. Keep in mind that in this example, obstacle detection and robot movement are simulated for illustration purposes. In a real robotic application, you would have actual sensors and control mechanisms to detect obstacles and move the robot accordingly. Next section is about for loops. In Python, a for loop is a control flow statement used for iterative execution. It allows you to iterate over a sequence of elements such as list, tuple, string, or any other iterable object. The basic syntax of a for loop in Python is like this. Here, element is a variable that takes the value of the next item in the iterable for each iteration. You can choose any valid variable name you prefer. Iterable is a sequence of elements that can be iterated over. It can be a list, tuple, string, range, or any other iterable object. The code block under the for loop is indented and executed repeatedly for each element in the iterable. The loop continues until all elements in the iterable have been processed. It's important to note that you can combine for loops with conditional statements such as if-else and other control flow statements to create more complex logic within the loop. Let's see some simple examples to get the idea. It is possible to use for loop with strings. For instance, if we say for leather in robotics, print leather, it will go ahead and print all the letters in the word robotics. We can also use for loops with other data types like lists. If I create a list of robotics engineers and then I say for robotics engineer in robotics engineer list, print robotics engineer, then it will go ahead and print the names of the robotics engineers in the robotics engineers list. So this is basically iterates over the robotics engineers list and print out each robotics engineer name in the console. Here I want to use for loop with the indexes. Here we used for loop to iterate over the indices of a list called robotics engineers. It prints both the index and the corresponding element in that list. You can also loop through a series of numbers or range of numbers. Here we use the for loop to iterate over a range of numbers from 3 to 9. Note that the range function in Python generates a sequence of numbers starting from the first argument and ending at 1 less than the second argument. So the numbers generated will be from 3 to 9. We also have nested loops or loops inside loops. That is the topic of the next section. A nested loop means loops inside the loops. You can iterate over the elements of a 2D list using nested loops. The outer loop iterates over the rows, and the inner loop iterates over the columns. This allows you to perform operations on each element of the grid. Let's see an example that demonstrates iterating over a 2D list. Here, we first define the 3x3 matrix, which is a list of lists, and then use nested for loops to iterate through each row in the matrix. And within each row, we iterated through each element, and then printing each element on a separate line. So to put it another way, in this example, the outer loop iterates over each row of the matrix, and the inner loop iterates over each element in the current row, and then prints its value. In the next section, we will start talking about classes and objects in Python. In previous sections, we saw different data types in Python, like numbers, strings, and Boolean values, and structures like lists or dictionaries that can store our data. But there are lots of other things that cannot be represented by these data types, like a person, a computer, a robot, etc. These cannot be covered by the data types that we have in Python. With classes and objects, we can create our own data types for anything we want. For instance, a robot data type represents a robot. We can store all the information that we want to know about the robot inside that data type, and Python will create a class for it. In Python, classes and objects are the fundamental concepts of object-oriented programming, or OOP. Classes define the blueprint or template for creating objects, and objects are instances of those classes. Let's start by understanding the basics of classes and objects. A class is a user-defined blueprint or prototype that defines the attributes or data and methods or functions that an object of that class can have. It serves as a template for creating objects. In Python, a class is defined using the class keyword. With class, we can define our own data type. An object, on the other hand, is an instance of a class. It's created using the class as a template and has its own unique set of attributes and can perform actions defined in the class's methods. Once an object is created, you can access its attributes and call its methods using the dot notation. Objects created from the same class can have different attribute values while sharing the same methods defined in the class. Classes and objects allow you to organize and encapsulate data and functionality in a structured manner, making code more modular, reusable, and easier to maintain. Let's define a simplified robot arm class that has the attributes of name, length, weight, color, and position. We want to define two methods in this class. Move, that moves the robot's position by certain angles, and display info, that displays information about the robot, including its new position. First, we define a Python class called robot arm. This class represents a robotic arm, and it has the attributes of name, length, weight, color, and position. It also has methods like init that initializes the attributes of the robot arm object when it's created. Now let's create an object of the robot arm class and utilize its attributes and methods. So here we create a new instance of the robot arm class with the attributes of name, which we called it arm row. And the length is 50 centimeter, the weight is 10 kilograms, and its color is black. And it is started from the initial position 0 degrees. After this, we can call the move method to update the arm's position by 45 degrees and display its information using the display info method. I again want to call move method to further change the arm's position by minus 15 degrees and display the updated information. Note that we can also access to everything in the class from outside of the class using import function. Let's take a look at the robot arm class that we created again. So in the Python environment, we can import that class by using the import function, and all of the objects can access the methods in it. So we would write from robot arm, import robot arm. Here the first robot arm refers to robot arm.py that I created, and I named my Python file as robotarm.py, and the second refers to the class name. And after importing robot arm, any object that is created here can access to the attributes and methods of robot arm class. As you can see, we can access the methods inside the class by importing it. And again, the arm1 object can access all the functions inside the robot arm class. So this was an introduction about classes and objects in Python, which is the basis of object-oriented programming in Python. The next section is about inheritance. Inheritance is a fundamental concept in object-oriented programming that allows classes to inherit attributes and methods from other classes. It enables code reuse, promotes modularity, and facilitates the creation of hierarchies and relationships between classes. In Python, you can create a new class by deriving it from an existing class. The existing class is called the parent or base class, and the new class is called the child or derived class. The child class inherits all the attributes and methods of the parent class and can also add its own unique attributes and methods. Inheritance allows the child class to reuse the code and behavior defined in the parent class while extending or modifying it to suit its own specific needs. It promotes code reusability, reduces redundancy, and allows for more flexible and modular code organization. In other words, we can define a bunch of attributes and functions inside the class, and then we can create another class and we can inherit all of those attributes. We can basically have one class that has all the functionality of another class without having to physically write out any of the same methods and attributes. Let's explore the concept of inheritance with an example. Suppose we want to create a program to simulate different types of robots. We can start by creating a base class called robot that defines common characteristics and behaviors of robots. Here's an example. Here we created a class named Robot. This class has attributes to store the robot's name and the number of degrees of freedom it has. It also includes methods for introducing the robot and indicating that it can move. As we talked about this before, init initializes the object with the name and the number of degrees of freedom. These attributes are stored as self.name and self.dofs. The method introduce prints an introduction message stating the robot's name and the number of degrees of freedom it has. The method move prints a message indicating that the robot can move. Now let's say we want to create specific types of robots, such as a wheeled robot and a flying robot that inherit from the base robot class. We can define these classes in separate Python files. For example, for the wheeled robot, we can write this code. Here, we created the class wheeled robot that inherits from a base class robot. This inheritance allows wheeled robot to inherit properties and methods from the robot class. The wheeled robot class has its own constructor or init, which initializes the num_wheels attribute, and it also overrides the move method to provide a specific behavior for wheeled robots. So in this code, first, we imported the robot class, then we defined the wheeled robot class that inherits from the robot class. In the constructor or init of wheeled robot, it takes three parameters: name, DOFs, and number of wheels. It calls the constructor of the base class or the robot class using super.init name and DOFs to inherit the name and DOFs properties from the base class or the parent class. It initializes its own number of wheels property with the provided num_wheels parameter. The move method of wheeled robot is defined, which overrides the move method from the base class. In this new move method, it first prints a message specific to wheeled robots, indicating the number of wheels. Then it calls the move method from the base class using super.move. This code is a good example of using inheritance and method overriding in object-oriented programming. Now we want to create another specific type of robot, like a flying robot that will inherit again from the robot class. So we will create another class and call it flying robot, which also inherits from the robot class. Similar to the wheeled robot class, the flying robot class has its own constructor, and it overrides the move method from the base class or the parent class. This allows you to create flying robots with the specific attributes and behavior. So again, we first import the parent class or the robot class, and then define the flying robot class, which also inherits from the robot class. In the constructor or init of flying robot, it takes three parameters: name, DOFs, and max altitude. It calls the constructor of the base class using super.init name and DOFs to inherit name and DOFs properties. It initializes its own max altitude property with the provided max altitude parameter. The move method of flying robot is defined, which overrides the move method from the base class. In this new move method, it first prints a message specific to flying robot, indicating the maximum altitude. Then it calls the move method from the base class using super.move. This example also follows the same pattern of inheritance and method overriding as the wheeled robot class. Let's now create some instances of these classes and see how they behave. So here we are creating instances of both wheeled robot and flying robot and calling the introduce and move methods in them. The robot class has an introduce method which both wheeled robot and flying robot inherit, and each subclass, wheeled robot and flying robot classes, has its own implementation of the move method in addition to inheriting the move method from the parent robot class. So we first import the two wheeled robot and flying robot classes from their respective modules. Then we create an instance of wheeled robot and we call it robot 1 with the attributes rover, which is its name, and it has 3 degrees of freedom, and 4, which is the number of wheels of this robot. Then we will call the introduce method on robot 1. Then we will call move method on robot1. Robot2 is an instance of flying robot class with the attributes DroneX, which is its name, with 6 degrees of freedom, and 100, which is the max altitude. Then we again call the introduce method on robot2, and then we call the move method on robot. So here we saw that the instances of wheeled robot and flying robot inherit the introduce and move methods from the robot base class. They also have their own specialized implementations of the move method specific to them. Here you saw that by using inheritance, we can easily extend and customize classes to represent different types of robots while reusing common code from the base class or the parent class. In the next section, we will read from files. Reading external files like a text file or a CSV file in Python is a common task when working with data or text files. Let's say you have a file called sensor data.txt that contains readings from a temperature sensor in different timestamps. Each line of the file represents a timestamp temperature reading. For instance, here's the example content of the sensor data.txt file. Now we want to read data from this file that we call sensor data.txt. This line of code opens the specified file, which is sensor data.txt, and it will read from it. With statement ensures that the file is properly closed after the block is executed. Then we will iterate over each line in the open file. The line variable here represents the current line being processed. After that, since our file contains lines and each line in the file contains a timestamp and temperature separated by a comma and a space, we want to split those. So we want to split the current line, which is read from the file, into two parts using the comma and a space as the separator. The strip method removes any leading or trailing white space characters, so that's for that. Then we would print the extracted timestamp and the temperature. So to summarize, in this example, we first open the file using the open function with the file name sensor-data.txt, and the mode is R for reading. The with statement ensures that the file is properly closed after we finish reading. Inside the loop, each line is split using the split method with comma as the separator. This separates the timestamp and temperature values. The strip method removes any leading or trailing white space from the line. You can then process the data as per your requirements. In this example, we simply print the timestamp and temperature for each line. Here, make sure that the sensor-data.txt file is in the same directory as your Python script, or provide the full path to the file if it's located elsewhere in your system. There are also writing and appending modes onto files in Python that have less applications for our cases on robotics. So if you like to learn them, you can learn them on your own. In the next section, we will talk about modules and pip command. In Python, a module is a file containing Python definitions, statements, and functions that can be imported and used in other Python programs. It provides a way to organize and reuse code, making your programs more modular and easier to manage. Modules are an essential concept in Python programming and are used extensively in large projects. Here's a breakdown of the key aspects of modules in Python. The first aspect is creating a module. A module is simply a Python file with a .py extension. To create a module, you can start by writing your Python code in a file and save it with a meaningful name and the .py extension. For example, if you create a module called like mymodule.py, it can be imported into other Python programs. The other key aspect of modules in Python is importing modules. To use a module in your program, you need to import it. You can import an entire module or just specific objects like functions, classes, and variables from it. The import statement is used for importing modules. For example, if we say import my module, it will import this module into your Python code. The other aspect is accessing module objects. Once a module is imported, you can access its objects using dot notation. If you have a module named myModule and it has a function called myFunction, then to access that function within that module, you will write myModule.myFunction. The other aspect of modules is module aliases. You can assign an alias to a module to provide a shorter or more convenient name. Aliases are created using the as keyword during the import statement. For example, you can import my module as mm, and then from that moment you can use mm instead of the module name. For example, if you want to use the my function from it, you would just say mm.myfunction. The other aspect of modules is importing specific objects. If you only need certain objects from a module, you can import them directly rather than importing the entire module. This approach can save memory and improve code readability. For example, you created a my module, and then you would say from my module, import my function, my variable. So you only import my function and my variables, certain objects from that module. You can create your own modules. To create your own module, you can define functions, classes, and variables within a Python file. You can use these modules in other Python programs by importing them. It's good practice to include a brief description of the module's purpose using docstrings to provide documentation for users. A docstring is a string at the beginning of a module or function that gives extra information about it, and it's for just human users to understand what the module or the function does. Python also has a standard library modules. It comes with a vast standard library that provides many modules for common tasks. These modules offer functionalities such as file input output, mathematical operations, we use math library before, networking, regular expressions, and more. You can import and use these modules in your programs without any additional installation, and we did it in previous sections. There are also third-party modules. In addition to the standard library, Python has a rich ecosystem of third-party modules available for variable purposes. These modules are created by the Python community and can be installed using package managers like pip. There are also some popular third-party modules. An example is Numpy, which is for numerical computations, and it's very common in robotics. In the next section, we'll talk about Python interpreter and getting input from users. Python interpreter is a little environment that we can use to execute Python commands. To use the Python interpreter, you should first open the command prompt that for Ubuntu it is Ctrl-Alt-T. So first open the terminal, then type Python 3 to see the latest version of Python 3 and getting into the Python interpreter. But typing Python 3, you will get into the environment of Python interpreter. Now you can write quick Python code and quick test it. For example, we want to get the user's name and age and then greet them using this information. We take information from the user first in Python using the input command, and then we pass prompt to it. Then we store it in the variable name and age, and then we can do some operations with those variables like printing the greeting message, etc. This environment is really good for quick testing. This environment isn't for development, so it's just for quick testing, and when you want to just quick test something to see what the output is, this is very useful environment. Let's go to the next section, which is try and except statements in Python. The try and except statements in Python are used to handle exceptions. An exception is an error that occurs during the execution of a program. If an exception is not handled, the program will crash. The try block contains the code that you want to run and that might throw an exception. The except block contains the code that you want to run if an exception occurs. Let's see a divide by zero example. We first define a function named divide numbers, and we pass two parameters to it, x and y. Then we will use try except block to handle the case where the division by zero occurs. Here, if we call the function and write like print divide numbers 10 and 2, this should result in a successful division since 10 divided by 2 is equal to 5 and it's not divided by 0, so no exception is raised. So the result of the division 5 will be printed. But when we try to divide 10 by 0, this should result in a 0 division error since division by 0 is not allowed in mathematics. When this exception occurs, the code inside the except zero division error block is executed, which prints the division by zero error message. To summarize this code, the divide numbers function takes two numbers as input and returns the result of dividing them. The try block tries to divide the two numbers. If the denominator is 0, a zero division error exception will be thrown. The except block catches the zero division error exception and prints a message. The first line of output is the result of calling divide numbers with 10 and 2 as input. The second line of output is the result of calling divide numbers with 10 and 0 as inputs. The zero division error exception is caught by the except block and the message division by 0 is printed. The none at the end is the result of the second print statement. This is because the divide numbers function doesn't have a return statement for the case where a zero division error occurs. In Python, a function that doesn't explicitly return a value implicitly returns none. So we should, instead of print inside the function, we should use return statement. In order to handle other exceptions, we can use more except blocks. For instance, here we also handled the invalid input error as well. The first except zero division error block specifically handles the case when a division by 0 occurs, returning the string division by 0 error. The second except block is a catch for any other exceptions that may occur. It returns the string invalid. So here the updated function effectively handles both the specific case of division by 0 and any other unspecified errors by providing appropriate error messages. This approach allows for better error handling and communication of issues that might occur during the function's execution. Let's now go to the next section and talk about a specific library in Python named Numpy that we are really interested in robotics. Numpy is a powerful Python library used for numerical computing. It provides efficient array operations and mathematical functions, making it widely used in robotics for tasks such as data processing, simulation, and control. In order to use Numpy, we should first install it. First, open up a terminal in Ubuntu by pressing Ctrl-Alt-T. Update the system as usual and then install pip if it's not already installed. Remember that pip is for installing packages in Python. You can do so by typing sudo apt install python3 and then -pip. Enter the password and wait for the pip to be installed. Check to see if pip is installed properly by typing pip version. Now you can install Numpy by typing pip3 install Numpy. Type Python 3 to enter the Python interpreter environment and then test to see if the Numpy is installed properly by creating an array using the Numpy library. Now that the Numpy library is installed and we check to see if it's working properly, let's see how we can use it in our VS Code IDE. We first begin by importing the Numpy library and giving it an alias np. Then we created two Numpy arrays, v1 and v2, and we gave them some values. Now we want to do some basic element-wise vector operations. Here we want to print the value of the array v2 and the result of adding v1 and v2 together element-wise. Now let's show the element-wise multiplication of the arrays v1 and v2. The shape attribute of the Numpy arrays is used to display their dimensions. Initially, when we check, the shape of v1 is 6 by nothing, indicating a one-dimensional array with 6 elements. To make it a column vector, it's reshaped to have dimensions of 6 by 1 using double square brackets. Now I want to show how to perform matrix multiplication using the matmul function inside the Numpy library. We can achieve this by matrix multiplication between v1 and the transpose of v2, which results in a 6 by 6 matrix. .t attribute is used to obtain the transpose of a matrix. The shape of v2 transposed is 1 by 6, indicating a row vector. In Python 3.5 and later, the @ operator can be used for matrix multiplication. So here we want to show a matrix multiplication using this operator. we see that the matrix multiplication of the transpose of V1 and V2 is a 1x1 matrix, essentially a scalar. Now we want to create a 2x6 matrix using Numpy. We create a matrix as a Numpy array and we call it X. This array is constructed using nested lists, where each sublist represents a column of the matrix. The matrix is created with 2 columns and 6 rows. Again, we use the dot-shape attribute of the Numpy array X to display the dimensions of the matrix. The result of x.shape is 2x6, indicating that the matrix has 2 rows and 6 columns as we initially decided to do so.